In solving systems by graphing, we said that a solution is the x and y value that makes the equation true being replaced in both equations. So if in the system there are two equations, but after you find a solution, you have to replace in both equations the x and y values to see if you have true statements. If the equation works in one but not in the other, it's not a solution. So we always have to make sure we check in both equations. In the systems, always said that the three possible solutions are one solution if the two lines cross in a point, and two lines can only cross in one point. No solution is when the lines don't cross, and the lines don't cross only if the lines are parallel. So for any parallel line, or the lines never intersect, there will be no common point and no solutions. What is a misconception sometimes? People trace two lines and they are not parallel, they are not intersecting, but does that mean that it's going to be no solution? No. Just because you didn't trace them long enough, it doesn't mean that it's not going to be a solution. These two lines are not parallel. There will be a solution. If you're tracing them or extending them longer, they will cross somewhere eventually. If something gets out of the graph, get a bigger piece of paper and we'll learn other ways of solving without the graph, how to identify the solution if it's a bigger number. But anyways, the idea is, in order to say that the system has no solution, the lines must be parallel. Parallel, never intersect. If the slopes are different, they will cross somewhere, sometime, eventually they will cross. If the slopes are the same, the lines are parallel, the lines will never cross. So careful with the no solution. And if we have two overlapping lines, then we have infinitely many solutions, and any point of one line is the same as the other because they are overlapping, so infinitely many solutions. Out of the three situations that we have, one solution, no solution, and infinitely many, we had all the equations in slope-intercept form, and I'm gonna go over a few more examples just to clarify a few things about graphing and identifying solutions. So for the next example, number 4, I have two equations, y equals 2x minus 3. When we graph, we start at the y-intercept, -3 on the y-axis. So that is the starting point in graphing. The slope, 2/1 being positive, it is an upward line with 2/1, so 2 by 1 upward, 2/1 from the y-intercept, 2 by 1, 2 vertical, 1 horizontal. That would be upward line, up to the right, upward towards the right side of the graph. That is a positive line. Second one is going through 7 on the y-axis because 7 is the y-intercept. 1, 2, 3, 4, 5, 6, 7. That is the starting point in graphing. Then the slope, -1/2, is 1 vertical, 2 horizontal in the negative direction. So 1 vertical, 2 horizontal. That would be a -1/2 downward. 1 by 2. 1 vertical, 2 horizontal. From 7, 1 vertical, 2 horizontal. Extending in the opposite direction will be up left. The intersection point is the solution, and we need to make sure we check it. So we have one solution, 4, 5, where the x value is 4 and the y value is 5. So in our system, we have one solution because the lines intersect in one point, and that 4, 5, x4 and y5 has to work for both equations. So in the first equation, I'm going to substitute instead of y5 and instead of x4, and we have 5 equals 2 times 4 minus 3, where 8 minus 3 is 5. So 5 equals 5, and that is a true statement. In the second equation, when you have half that multiplication, I like to rewrite it as 1 negative times 4, the x value, divided by 2. So using the rule, instead of saying half times the number, I need to multiply the negative 1 times the number and then divide by 2. So negative 1 times the 4 and then divide by 2. That's negative 2. Negative 2 plus 7 is 5. And the y value is 5. True statement on both sides. Every time you find a solution, make sure you check it in both equations. In the second system, we have y equals x minus 3. The coefficient of x is 1, and at a slope that will be 1 by 1. Being positive, we have to go upward 1 by 1. That is your direction of the line going through 3 on the y-axis, because that is the y-intercept. Upward 1 by 1. Upward, up, up, up. You can extend it for accuracy and identifying the solution. Y equals 4. This is a horizontal line going through 4. The slope of this line is 0. The complete equation will be y equals 0x plus 4. 4 is a constant. 4 is not multiplied by x. This is the constant 4. So we have y equals 4. It's going to be a horizontal line going through 4 on the y-axis, because y-intercept is 4, and then we have a horizontal line going through, and the solution will be right here where the lines intersect. So we will have one solution because the lines intersect in one point, and the solution will be 7, 4. If you look at this equation one more time, y equals 4, that means that this problem already tells you the y value. The y has to equal 4. So the y value of the solution is 4. If you graph the two lines and you do something incorrectly and you have, instead of y, 4, something different, then clearly something is wrong, because this problem already tells you the y has to be 4. All you have to do is find the x. So after graphing, the x value is 7. Let's see here, if you substitute an equation, instead of x 7, instead of y 4, 7 minus 3 is 4. That's a true statement. And in this one, where it says y equals 4, we already found that y equals 4, but by substituting it in the equation, we have 4 equals 4, which is a true statement as well. In the next equation, we have negative, y equals negative. Negative slope means it's a negative line going through 4 on the y-axis, because 4 is the y-intercept. So your slope is going to be downward, and it will be 2 by 1. Starting at 4 on the y-axis, we're going downward 2 by 1. That is a negative direction of the line. 2 by 1, 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 little steps all the way throughout, as many times as it fits. And the more the better for accuracy and identifying the solution. Second line has 1/3 slope going through negative 3 on the y-axis. 1/3 is positive, and it is 1 by 3. 1 vertical, 3 horizontal, upward. 1/3 positive, 1 by 3. It is going through negative 3, so the line going through negative 3, upward with a count of 1 by 3. Or it can go down left, or it can go upright, upright. As long as the line is going upward when being traced from left to right. upward, positive slope, downward, negative slope. Solution is the cross point of the two lines, so we do have one solution here because the lines intersect in one point, and the solution is 3, negative 2. The x value 1, 2, 3, y value 1, 2. So 3 for x, y negative 2. Check. When we check, we have to check the solution in both equations to make sure it is a true statement. Next example. Number 7. Y equals negative x. That is y equals negative x, negative 1 is the slope. So negative 1 is the slope downward, 1 by 1. The y-intercept will be 0. So this is a line that goes through 0 or through the origin and has a negative 1 by 1 slope. It means the line goes downward after connecting left to right. So that's a downward line. And the slope is negative, count 1 by 1. The second equation says x equals 3. So here is one variable, x equals 3. If the x equals 3, it means that the x value of your solution is 3. And on the x-axis will be a vertical line. So the vertical line going through 3. The x values on this line can be only 3. Solution 3, negative 3. So what we see at this time is that the graph is going to represent the intersection of two lines. So we will have one solution, and the solution will be 3, negative 3. X value 3, y value negative 3. When we check in the equation where it says y equals x, negative x means negative 1 times x. So when we substitute, instead of y negative 3, negative 1 times 3 is negative 3. So that's a true statement. And then in the second equation, x has to be 3. So substituting 3, does 3 equal 3? Yes, that makes a true statement as well. In the next example, we have two equations with the same slope. Y equals 3/4 x minus 5 and y equals 3/4 x plus 7. If the equation have the same slope, same direction, same orientation, we will have parallel lines. So 3/4, 3/4 upward is one line. And the second line has to go through 7 on the y-axis, and it has exact same slope. If it is the same slope, it means same direction, same orientation. If the lines have same direction, they are going to be parallel. Parallel lines will never intersect, they will never cross. That means that the system will have no solutions. So for the answer, we can say no solutions, parallel lines never intersect, and we answer no solutions only in systems with parallel lines, because parallel lines never cross. And in the last example, we have equations that are completely identical. It means that if we graph them, they are the same line. Y equals x minus 5, so through negative 5 we have positive 1/1 slope, and that is the first line. In the system we have two lines, but they are completely identical. So when I graph the first line and then I graph the second line, I go right over it because I start at negative 5 and I go with the same exact slope. So I have to go right over it. It means overlap it. So once I overlap it, I have exact same line. For the answer, we'll say infinitely many solutions. To prove it, you can pick a few random points. So let's say pick this one, 5, 0. Or y will be 0, and then x is 5. 5 minus 5 is 0. That would work. Let's say this one, 2, negative 3. If the y is negative 3, 2 minus 5 is negative 3. That would work. Or let's say this one, negative 3, negative 8. I can pick any point and it will always make a true statement, because on two overlapping lines, any point of one line overlaps with the point of the second line. So therefore, we have infinitely many solutions.